Hey, hi everyone. I hope you are having a great day till now. So let's get started with this, with my talk, which is on Django applications, how to scale them, and what mistakes people go through or we went through while we were developing something. I'll be talking about everything in the upcoming slides. So before we get into uh, the Django applications or the microservices thing, I want to introduce myself. So something about me, like I'm a software engineer at Microsoft, currently working since like 1.5 years there. Apart from software engineering, I'm also a content creator on YouTube and on LinkedIn. So I generally post content related to software engineering and a similar niche. Then previously, I've also interned at Microsoft and Stack Guardian, which is an infrastructure as code platform built completely in Django, and we'll be talking about that platform only, like what experiments we did, what processes we followed, and what mistakes we came across while building the Django applications for that particular platform. Then I'm also a ACM ICBC regionalist and Google Code Inventor for TensorFlow organization in 2019. I've also spoken at Hong Kong PyCon Hong Kong 2022. Yeah, so we have a huge family of more than 100,000 audience combinedly over YouTube and LinkedIn. Okay, cool. Let's go ahead. Let's go ahead with our agenda for today. So what's in store for you folks? So we'll be kickstarting everything with monoliths, about the introductory part of monoliths and why people or why companies are moving away from it. What are microservices? Why one should care about microservices? And then we'll be moving towards Django microservices and how to build Django microservices, what mistakes to avoid with Django applications while following the microservice architecture, and then a small Django trivia at the end. So if you folks are into development and in software engineering, you mostly hear about two terms, monoliths and microservices. They are intensely discussed topics among in the software engineering field, as well as with respect to technical interviews at big tech companies. So we will be discussing a lot during the whole thing. Now let's move ahead. So you might have seen this picture, floating on the internet a few months back, actually, where randomly some monoliths started appearing in Utah or Mongolia and many other places around the world. But we don't care about it. We care about monolith architecture, which basically means everything in one piece. So when we talk about monolith architectures are those which have huge systems and it's just one machine running the whole system, while microservices are just tiny machines, each running a single function, having a dedicated database, and like clients connect to different services as per their requirement in a microservice. And whereas in a monolith, all the clients, all the requests goes to a single machine which is having all the logic. This is what most of the people think, but this is actually, there are two major misconceptions here which people have. Microservices are not just a single machine. We can scale out microservices and they can be horizontally scaled out. So that's a major misconception that people have, that microservices is a single huge machine running everything, which is wrong. And at the same time, microservices are not actually micro in nature. They are actually a complete business unit for a particular organization. So these are the two major misconceptions that people have, that monoliths and microservices. So let's jump on to what monoliths actually are. So monoliths are a single tiered applications in which different components are combined into single program to basically build a single platform. So that is a general definition of monolith. But why monoliths actually sucks? Although there are a lot of advantages, but the disadvantages are more convincing for people to move away from monolith architecture. So first and foremost is context for new members. Let's take an example. You're a team of 4 to 5 members, and in your team you're building a complete some platform, something. and a new member comes into your team. So in a monolith architecture, if you're building a platform in a monolith architecture, the new member requires a lot of context and need to understand the whole system in order to get started. In order to work even on a single thing, the person needs to know the whole system, the whole code base. Reason being, everything, anything and everything in a monolith architecture is closely coupled. Like each and everything is somewhat touching each other, and that's why the person who is get want to get started needs to know each and every part, or each and every moving part of the application. That is one of the major disadvantages why companies are moving away from monolith architecture. Then comes the parallel work and development. So deployments are very complicated when it comes to monoliths. Reason being, any small change requires a new deployment, and each deployment requires continuous monitoring as well. And it's get tricky when multiple members are working on different code bases, because as I earlier mentioned, anything and everything are tightly coupled, and each and everything that you touch upon touches indirectly or directly touches all the other parts in a monolith architecture. So deployments become very difficult, and team needs to deploy things very frequently if they are making changes very frequently. Testing is difficult. So since the monolith architecture is not really decoupled, so even testing gets difficult as everything is touching everything. Single point of failure. So since in monolith everything is combined or bundled into one single program, into a single system, there is a too much responsibility on a single server, and if anything fails, a server crashes, all the servers will also crash and the system will shut down. So this is one of the major disadvantages why companies move away from monolith architecture in order to avoid the single point of failure. Then comes reliability. So in case anything happens in any of the module, then for example memory leak happen in any of the module, which can potentially bring down the entire process. And moreover, all the instances of the applications are identical, and the bug will impact the whole system and may affect the availability of the entire application as well. Now comes the adaptability. So regardless of how easy the initial stages seem, monolith applications have difficulty in adopting new and advanced technologies. Since changes in languages or framework affect the entire application, it requires efforts to thoroughly, work with app details, and hence costly, time consuming, and requires more effort as well. So that's why it is preferred as soon as your organization grows, start moving to. So we'll be talking about how to move from monolith to the microservice architecture in some time. Okay. Yeah, that's it about why the monolith sucks. So monolith application can also be challenging to scale when different modules have conflicting resource requirement as well. That is also one of the major disadvantages why monolith sucks. And not just that, there are a lot of companies who actually ditched the monolith architecture and moved away to the microservices thing. So a few example of them are, okay, second. A few example of them are Amazon, which is e-commerce based, not just e-commerce. They have a lot of businesses, but when we talk about the Amazon e-commerce business, everything and anything on Amazon.com is kind of a microservices following a microservice architecture. The authentication services is different, and the payment services different, profile services different, product listing services different, orders services different. Everything is kind of disintegrated into, decoupled into loosely coupled business units. Then Netflix is also one of the examples. Uber, eBay. If yeah, I'll give you an example which is still a monolith, is Instagram, and then comes Stack Overflow. These are two of the major companies which are still running on a monolith architecture, although they have scaled out at a humongous scale, but they're still a monolith. So let's talk about why microservices and what are those, because if in today's world you'll see everywhere you go you see microservices. What are microservices? Let's take an example. If you're a user, or you're using a mobile phone and you want to authenticate yourself on different websites, you use a authentication service, or if you want to pay somewhere, you use the payment gateway or the payment service of that particular platform. And based on your requirement, you make network calls to a particular service. And this is actually what microservices architecture is, where two different services which have different responsibilities, and they are like not tightly dependent upon each other. So we separate out them and make them two different services as per, and the user will make network calls to the 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 as per their requirement. They call the different services. So this is actually the microservice architecture. If we go with the general definition of microservice architecture, is just that when different when an extensive application is built out of a bunch of modular services, where each module represents a business unit or targets a business goal, uh, and interact with other services or other modules using network calls, is actually the microservices development approach. So this is the general introduction of what microservices are. And as I mentioned the small phrase as well, loosely coupled components. I by mistake added couples. Sorry for that. Okay, moving ahead. But yes, you folks might have understood, okay, these are microservices, but why one should use microservices? What advantages they are providing, and why companies are moving? Like, what is that? Okay, monoliths have their disadvantages, but what are the convincing facts about microservices which are persuading the companies to move to that architecture? So the most obvious advantage of microservices is that it's very easier to scale. And because the entire system is a set of services, each concerned with a different responsibility or different purpose, data, and interacting with each other. So it's very easy to scale based on which service is being consumed more. So which particular service is getting more traffic, and the you can scale it out. Then comes enable ownership and less context. So when in microservices, you have different business units running and which are loosely coupled, having their own functionalities. So whenever a new member comes in, they just have to know about that particular business unit or that particular microservice. They don't have to. So for example, a chat developer don't have to know what the analytics microservice is doing, or what the logic goes in, or what happens under the hood of that particular microservice. So the chat developer don't need to have the complete context, but they just have to get the idea of their particular microservice. And this also enables ownership, because now that person, the new member, needs to focus on a particular service, and he or she can, or they can get started very quickly and uh, ramp up quickly as compared to the monolith platforms. Then comes parallel development. So development is very easy. As I earlier mentioned, a chat developer team doesn't have to depend upon what analytics team is doing, analytics service is doing, because they are loosely coupled and there are lesser moving parts. So they are not, if they are doing something, it's very rare that it will affect the chatbot service. Then the final, similarly, testing and deployments becomes very easy, because now uh, for example, authentication team needs to write test cases for their microservice only. They don't have to care about what the other teams are doing, what payment service is doing. They just have to care about if their authentication service is running end to end. And this becomes very easy for deployments as well, because now the payment service can add changes and deploy their service irrespective of the fact that auth service has added any changes or deploying or not. So the testing and deployments become more convenient when it comes to microservice architecture, and then improve fault isolation as well. Now the final good point is the improve fault isolation, which is there are very less moving parts, or things are very much transparent, not hidden. For example, if one of the service is getting a lot of load, you can scale it out or add more compute to it. Whereas in monolith, you cannot really understand which particular thing or module is causing the issue. That's why you have to scale the whole architecture, and which brings in more cost and more compute and more effort as well. So it has, like, microservice architecture has improved fault isolation, and there is no single point of failure. Cool. Okay, let's move on to our next thing. So even though microservices architecture seems very convincing, but it has a lot of challenges. So one sort of disadvantage with microservices is that, or I would say this is the biggest disadvantage, that is they're very difficult to design. You require a great architect to actually, understand and get you present the idea to actually separate out concerns, which is the most difficult part. So it happens many of the time that maybe some of the services would be divided into far more parts which are not even required at all. For example, if service 1 is interacting with service 2, and like service 1 is only interacting with service 2, then like we have made them as separate services. So even though they are like service 1 is only interacting with service 2, so ideally they should be combined and made into a single service, since there is no dependency of service 1 uh, on any of the other services. There is only one network call happening, only direct dependency is there from 1 to 2, and there is no other, like service 1 is not talking to any of the services but only to service 2 all the time. So it's not a good idea to divide them into two but combine them into one. So that is the point where the problems happen. Second is inter-service communication. So inter-service communication is comparatively slow. Obviously, it's a network call. It's not a function call which happens in a monolith architecture. It requires a remote procedure call or a HTTP call, which requires which happens from multiple APIs, and that's where it takes more time. Then comes more memory. So each microservice has its own database, and which require more money, more memory, and so that's one of the disadvantages of designing a microservice architecture. Now let's move on to the Django microservices, which is one of the most important thing of this particular talk. How to actually make the move, how to get started with microservice architecture, when you should move to microservice architecture if you're currently building a monolith. So the time when you move to a microservice architecture is not when you have a lot of scale or huge number of users, but ideally it should be when you should move to a microservice when your team has started scaling. When you have a large team, it's better to define ownership boundaries and decouple entire system into small services. You want your product teams to be working on different products. You want your deployment to be smooth, and that's where, like, when your team scales, you have a large number of team members, you can separate out them to and assign them to different services, and like you can have each team managing a separate product, separate each team will be managing the whole deployment cycle of a particular service. So it's the ideal way to move to a microservice is when your team scales and not when you have a huge number of users. So the first step is to define the services you've required, and the easiest way to figure that out would be looking back to why you decided to split your services or why you decided to go to the microservice architecture, the driving business logic which is making you take this step. So each service should cater a business unit. It should be loosely coupled with other services. You need to, and it, like, some most of the time people think that when you have to move to microservice, you have to split the system into a lot of microservices, but that's not the case. Even big systems can only have like 2 to 3 or 4. It depends upon the team size. If you don't have a huge team size, you should not make 3 to 4. Like, there's a proper you can find it on the internet actually. So if team size and the microservice architecture you should follow, that's a scale that you can follow, where if you have a team size of 10, you can have two microservices. I don't know the exact numbers right now, but yeah. So the point here is one should make services loosely coupled. As I already gave an example, that you can make your profile service as a separate service, auth service as a separate service, order service as a separate service. So these are very simple and general examples, but when it comes to real world problems, it's somewhat different. When it comes to Stack Guardian, we have a marketplace, we have an orchestrator. So these are two different things which are loosely coupled. Like once the user gets something from the marketplace, that can be migrated to the orchestrator, but they are not interdependent upon each other. So they can be separated out. There are other things as well that went into Stack Guardian. Now, once an organization start moving to microservice architecture, they should have dedicated database for each service. It makes the read faster and makes the write lightweight. So that is also one of the things that one should consider. That is adding separate databases to each and every microservice or business unit they are moving towards. In Monoliths, communication happens via function calls, as I already mentioned. But in microservice architecture, when services are separated out, we need to use a network to send request and get the response. So what happens is we need to create a complete object at the receivers, and based on the requirements of the server, and then get the response out of it. So this can like be facilitated with a HTTP call or a remote procedure call through the REST APIs, and REST APIs can be used to achieve these. Right. So the engineering effort required for moving from monolith to microservices is massive, and the best way to separate out is if you're following a monolith architecture and you want to include a new service, try to make it in a form like, let's separate it out. Let's not include it in the current, but let's separate it out, and this will somewhat kickstart your way to move out of monoliths and get into microservice architecture. Okay, so now in front of you, this is general overview of what Stack Guardian is doing. So we are an infrastructure deployment automation of infrastructure deployment platform, where we take in your your configuration of infrastructure, and we have we allow the users or the customers to add policies around it, custom policies as well as ready-made policies, and then which can be automated, and then these configurations can be used to deploy their infra over different platforms like AWS, Azure, Google Cloud, and many others. You can check out Stack Guardian by searching on the internet. So while building Stack Guardian, we did a lot of research initially to get started, and that the code base evolved over time. After understanding what is working well and what is not, to continue to scale, we started thinking around how to design a microservice architecture, and here are some workaround that we did during the process. So we did a lot of mistakes actually, and then we figured out, okay, these are the things which doesn't work with Django, these are the things that works with Django. So these are some of the things that I'll be discussing right now. So before going to the major mistakes, one small point regarding creating apps in Django. Django tracks model migrations separately for each and every app that you have. If someone has foreign key linking models across different applications, Django migration system will try to create a dependency graph so that these migrations are run in the right order. Unfortunately, the calculations it do under the hood isn't perfect and can lead to some errors and even complex circular dependencies as well, especially when you have a lot of applications defined. So if you don't really understand the point of application, stick with a single app for your backend. And if you do want to create separate applications, or looking forward to go into a microservice architecture in future, be very explicit about it and minimize any dependencies between different applications. So you can start in a way that whatever application you're having in your Django source, those should not be tightly coupled. Then sorry. So as your system evolves, it will accumulate more and more migrations. So they will take longer and longer to run. So whenever you deploy, all the migrations runs in sequence, and Django incrementally playback every single migration starting from the first one in order to construct an internal state of database schema. This slows down the production deploys, and developers will also have to wait when they initially set up the local development database. So deployment takes a lot of time, as everything needs to, like, all the migration needs to run from starting to the end. And if you have multiple databases, this process will take even longer, because Django play all the migrations on every single database that you have, regardless of whether migration affects that particular database or not. It's a good practice to clean the migrations periodically. Either you can do it manually by deleting those, or you can use the built-in Django library, which is the Django's built-in squashing feature to clean up the migration history that you have. Then comes less bulky signals. So you might have came across, uh, if you are into Django development, you are aware of Django signals. So Django signal framework can be useful to kind of decouple events from actions, but one should use, but one use case that can be troublesome are pre and post save signals. So it works in the way that when something happens, you do something. So what mistakes we did, or generally people do, is they can be useful for small things, but putting too much logic in pre and post save signals can make the program flow difficult to trace and read. So it is advisable to limit your use of signals, or at least minimize the logic you put in into pre and post save signals. They are very helpful uh, to call out some actions, minimal actions, but they are some gets troublesome when you add a lot of logic into pre and post save signals. Then comes ORM as a main layer. Avoid you need to ORM is object relational mapper. So what happens is, in your particular application, you may be creating, deleting, or retrieving objects across the board from different endpoints, and this is not actually the right way to, like, not a clean way, because just in case you need to change anything, you need to make changes each and every point. For instance, you wanna create a object of model B whenever object of model A is created. So there are two ways to do it. Either you can use signals here, or the other way is, whenever the model saves in the save function only, you can create the object of the model B. This will work, but this is not the clean way, or this is not the ideal way to do uh, to do the thing. In order to get rid of this particular unorganized way or awkward way to somewhat create different objects using signals having a lot of logic, you can route everything, like whatever CRUD operations you have, through some kind of simple interface, maybe an API, where you have all the basically creating a single entry point that wraps up your ORM layer, and it gives you a clean entry point to add additional logic before and after the database events. Additionally, decoupling your application code a bit from the model interface will give you flexibility to move off from Django ORM in the future as well. So this gives added advantage if you create a over the if you put or wrap the ORM layer, because we did it, and whenever you want to make any changes, we just have to go to our one module, and we that and we have to just make changes there if you want anything before and after database events. So that is what we followed, and we didn't started with that architecture initially, but later on we realized that that's the ideal way. So that's it. Let's move on to the conclusion actually. So, well, both the approaches have their own pros and cons, as we discussed before, but it depends on, like, scenario or the product or the project requirements and which trade-off you want to choose. As a monolith approach best suits lightweight application, it is recommended to adopt monolith approach first, and depending upon the needs and requirements, gradually shift towards the microservices approach. So this is the conclusion. But before we end up, let me ask some of the interesting Django trivia questions. So, although we are recording this session, if you folks know, do mention the answers in the chat. What is the version of the latest Django release? If anybody knows, please comment it down. And in which year Django source code got open sourced? And then final, what is the first in like what is the approximate uh, value of the Django project right now? So if you know the answer, do make sure you comment it down. And if you have any questions, I will be there for like 5 minutes once the session will happen. And you can connect with me on my socials on Twitter. My name is Kushalvijay_, and on LinkedIn as well. And thank you folks for being such a nice audience for listening. I hope you had a great day ahead. Bye. Thank you.